Alright, here we are, 12.1. We're going to get our last unit of Algebra 2 underway with the fundamental counting principle. You can read the definition here, but really what this is doing is it's taking choices for a certain option times how many choices you have for another option, and so on for how many options you have. It makes more sense when you're looking at them here. So you got this restaurant here, you got 7 entrees, salads, drinks, desserts. So if you're going to choose one of those things, you take your choices for each. You got 7 choices times 3 choices times 12 times 5. So you multiply all those out, and what it means is that this place has 1,260 different types of meals that you can have that evening if you pick one of each of those different things. It's crazy. This is how Sonic gets to claim that they've got 120 million different drink combinations, because you think of all the different choices of types of drinks and soda flavors and syrups and all the other weird things that they put in stuff. You think about multiplying all that out, yeah, it ends up being a whole lot of stuff. Alright, so we're going to talk about license plates here a little bit. We're going to have 3 letters. So we're going to have a letter, and a letter. Then we're going to have 3 digits. So a number, and a number. There's 26 letters in our alphabet. There's 10 choices for numbers because 0 is a number. And so therefore you got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many different license plates do we have as options here? Well, how many letters do we have to choose from? We've got 26. Now if letters can repeat, that means we still have 26 choices here and 26 choices there. How many numbers? Well, there's 10 of them for each one of these as well. You're just going to take and multiply all those. No, it's a very large number. Comes out to be 17 million. So about 17.5 million different license plates you've got choices for here. Now, the next one starts to look at, well, what happens if we can't use 0 and we can't repeat letters? Alright, let's think about what that does to our numbers. If we can't repeat any of our letters, that means we have 26 choices here, but as soon as we take out a letter like L, now there's only 25 choices. We take out another letter, there's only 24 choices. So this is going to start limiting how many different options we have. Our first number can't be 0, so how many are left? 9. But I guess you can have 0 for the rest, so that's a 10 and a 10. So again, we're just going to multiply all those out, and this time we end up with only 14 million different combinations. So just that kind of minor little change, no repeats here, no 0 here, and we're starting to lose millions of different license plate combinations. And I'm sure you're just really intrigued by that. It's like, wow, this is fascinating. Alright, so Alan's having a pizza party, probably at Chuck E. Cheese, because that's what we do on the east side, right? He's going to have a cheese or pepperoni. How many choices is that? 2. Thick or thin crust, that's another 2 choices. With or without extra cheese, another 2 choices. How many different pizzas does he have? 2 times 2 times 2 makes 8. That's really it. 8 choices. Again, we're going to find 5 types of bread times 4 types of meat times 4 different dressings times 3 different drinks. So this is where you start to think, man, Subway has got a lot of different sandwiches, more than just the 12 $5 footlongs you see on the board. Multiply those out together, and what are we getting here? 240, I believe. 240 different types of choices there for Jim. Alright, Barbie's playing with her doll. That doesn't make sense. Barbie is the doll. Maybe there's Barbie with a Barbie. That'd be crazy. Alright, so we got 3 Jesses, 2 different hats, 4 pairs of pants, or 4 pairs of shoes for her doll. Alright, multiply those out. Now Barbie's got 24 different combinations of outfits. Guys, this is where you get to tell your girlfriend to shut up when she's saying she has nothing to wear. Let's think about all the different shirts that she might have in her closet, times all the different pants or skirts or other things, shorts in her closet, then times all the different shoes. Then you got to add in all the other accessories that she can put on multiply that out, I'm sure it's going to be a ton of different options. And she's still going to say, "No, I've got nothing to wear." Now you can prove her wrong. Alright, here we're going to have 4 different cylinders on our lock. So that's 4 different numbers you can show up. We got numbers 1 through 5. So we got 5 choices. It says it can be any of these numbers, so we're going 5 times 5 times 5 times 5. This is going to make 625 different numbers you'd have to check on that lock before you find the right one. Alright, these guys, we're doing this one because it's kind of like our semester exam question. So we got this situation where we're in New York. Somebody sees a couple parts, 3 different parts of the license plate, and we got to figure out what's left with these guys here. Alright. So there's no other weird things going on here. So how many numbers do I have for that spot? I've got 10 times 2 different letters, so that's going to be a 26 and a 26. So that's going to leave me with 6,760 different cars that could still have the 5, 6, and the M here with different numbers in the middle. Alright, here in Nevada, they're saying that we don't use the the O, because O could look like 0. So that would be confusing. So we've got these different parts. If we take out O as a possibility for our letter here at the M, that's just going to be 25 times 25, which equals our 625. Answer we just had a few minutes ago. Alright, we're getting close here. So we're doing the same thing. We're only looking for one thing. Well, if we're only looking for one, there's 25 possibilities, right? Makes sense to me. Let's move on here. Alright, so we got our 3 digits followed by 3 letters. Repeating and all that is fine. That looks like D. We got 10, 10, 10, 26, 26, 26. Now here it's saying that we cannot repeat things. So that's where we're going to go with this answer here. 10, 9, 8 because we're not repeating our number. 26, 25, 24 because we're not repeating our letter. Alright, and this is what one of your semester exam questions was. We've got 10 choices for a number times 10 choices for a number times our letter here, which is going to be 26. And guess what that is? 2600. And hey, we're done. And that's the fundamental counting principle. Make some good choices out there. We'll see you later.